Students, today I'll show you how to calculate the value of enthalpy of water vapor air mixture using a psychrometric chart. Now, the formula normally associated to find enthalpy for air water vapor mixture is H prime is equal to CS Tg minus T0 plus lambda into y prime, fine, where H prime stands for enthalpy of air water vapor mixture, CS stands for humid heat, Tg stands for the dry bulb temperature of air, T0 or T0 stands for the reference temperature, lambda basically latent heat of vaporization of water vapor, and y prime stands for humidity or absolute humidity. Fine. So if the information of humidity can be calculated using a given condition, then the remaining things can be quite easily calculated. Okay. Now let us see how can we proceed. Assuming that dry bulb and wet bulb temperature of air are given. Okay. Now this is a rough diagram of a humidity chart or a psychrometric chart. Okay. In the x-axis we have temperature, in the y-axis we have the humidity, which is kg water per kg dry air unit. Okay, and top of that it is the percentage humidity or the percentage saturation that basically starts from these points. Okay, now suppose dry and wet bulb temperatures are given. Okay, now what happens, let us draw first the percentage humidity or percentage saturation lines within this psychrometric chart. Okay, now these lines appear like this within a psychrometric chart. All right. Okay. Now what happens, suppose dry and wet bulb temperatures are given. Suppose TD stands for the dry bulb temperature and TW stands for the wet bulb temperature. So the first thing what you have to do, you have to draw a vertical line from the dry bulb temperature the way I am doing. Okay, and then from the wet bulb temperature you have to draw another vertical line. Now you have to understand that wet bulb temperature basically corresponds to a saturation condition. So the line which is originating from the wet bulb temperature point happens to intersect the 100% saturation line. Okay, so the vertical line arising out of the wet bulb temperature point, okay, it will intersect the 100% saturation line. Let us suppose this is point A. So once we have located point A, after that you know that for air water vapor system, wet bulb temperature lines are essentially the adiabatic saturation lines. Okay, so within the psychrometric chart we have adiabatic saturation lines similar to this. Okay, now from point A, following the trajectory of the surrounding adiabatic saturation line, doing in linear interpolation, you draw a line originating from point A and moving towards the vertical line originating from the dry bulb temperature. You will find the point of intersection B. So once you find out the point of intersection, go towards the right on the humidity axis and you will find the value of the absolute humidity, y prime. So once you find out the value of absolute humidity, okay, the rest is quite simple. You have to calculate the value of humid heat and for air water vapor system the expression is Cs equal to 1.005 plus 1.88 y prime. Okay, so y prime value just now I have shown you how to calculate. So use it to find out the value of humid heat, use the value of humid heat, use the value of dry bulb temperature as it is given in the question. T naught stands for the reference temperature, which is 0 degrees Celsius, and then lambda is latent heat of vaporization. The approximate value is 2500 kilojoule per kg. Put all the numbers and you can find out the enthalpy of air water vapor mixture. Okay, now this is one way to find out. However, there is an alternative way, and that is also quite interesting. To do that, the first thing is you have to closely focus on the psychrometric chart. Okay, so here I have shown you another demonstration of a psychrometric chart, okay, where actually I did not show you the percentage saturation or percentage humidity lines and the adiabatic saturation line. These lines are not shown, and instead of that I have shown you the other important lines for the sake of brevity. Okay, now as you can see, within this psychrometric chart there are several other lines are present. The line here, it basically is the enthalpy of the dry air. This line corresponds to this, okay, enthalpy of dry air. Then you have enthalpy of saturated air. There are two lines within the psychrometric chart. Okay, the first line, if you have a very good eyesight, you can see that it originates at some point within the chart and terminates in between. Okay, and the corresponding temperature, if you see in the x-axis, is around 48 to 50 degrees Celsius. Around this temperature, this enthalpy of saturated air line terminates. Okay, and if you just closely observe, if you just look at the top, the another enthalpy of saturated air line starts at 48 to 50 degrees Celsius and it just moves towards the y-axis. Okay, so basically within the psychrometric chart there are three enthalpy lines are there. The first one is enthalpy of dry air. The second one is enthalpy of saturated air, which originates and terminates round about 48 to 50 degrees Celsius. Then below 48 to 50 degrees Celsius, you have another enthalpy of saturated air line. Okay. Now, correspondingly, there are two enthalpy scales. Okay. This is basically the largest scale, where the enthalpy value basically ranges from 200 to 8000 kilojoule per kg dry air. Okay, so with respect to this higher temperature range saturated air line, you have to focus on the bigger scale, the larger one. Okay, and for the enthalpy of dry air and for the enthalpy of saturated air at a lower temperature, you focus on the lower scale, okay, which ranges from 0 to 280 kilojoule per kg. So in that way you have to segregate and read the chart. Okay, now for the same problem just now I have discussed, where dry bulb and wet bulb temperature of air are given, and using that we have seen actually how easily we can calculate the value of humidity, and using that you can calculate the value of enthalpy. Here also we can do the similar thing. Now suppose the dry bulb temperature is given. So this is the dry bulb temperature. So from the dry bulb temperature, draw a vertical line. Okay, if you draw a vertical line, it will intersect two different points, point A and point B. Point A corresponds to enthalpy of dry air and point B corresponds to enthalpy of saturated air with respect to the dry bulb temperature that is given in the question. Fine. Now what happens, it is very important that for any air water vapor system one should know what is the percentage of moisture present in air. Okay, one way to look at it is to get the value of absolute humidity, but the other way, which is more important, is to get the value of percentage of water vapor or the percentage humidity, because the formula that we are going to use, where percentage humidity term or the percentage saturation term is going to be used. Okay, so to do that, what you have to do, the same chart which I have shown you earlier, where we have found out with respect to dry bulb temperature and wet bulb temperature point B. Okay, so once you find out the point B, here we have calculated the corresponding value of humidity. But here we are supposed to find out the percent humidity or percent saturation correspond to point B. And you can easily do it. These are the percentage humidity lines. So following the trajectory of the percent humidity lines that is already given in the psychrometric chart, you draw another line following the same trend passing through point B. Okay, and the value that you get at the top scale, at the top of the figure, is going to give you the value of percentage saturation of air water vapor mixture at the dry bulb and wet bulb temperature. So this value needs to be figured out from the psychrometric chart. Okay, now what happens, using this plot, you have seen point A, which is intersecting with the dry air, okay, enthalpy of dry air line, and point B, which basically gives you the value of enthalpy for saturated air. Okay, now correspond to point A, you have to focus on the left hand side where you will get the value of enthalpy. Okay, because I've just told you that for the dry air and at a lower temperature you have to focus on the smaller scale. Okay, so you get the value of enthalpy, and for the saturated air you go towards the right, find out the value of enthalpy on the right hand side on the larger scale. Okay, so with respect to dry bulb temperature, we have calculated the value of dry air enthalpy, we have calculated the value of saturated air enthalpy, and also corresponding to the dry bulb temperature and wet bulb temperature, we found out the value of percentage saturation. Okay, once everything is done, we have a standard formula. The standard formula is, let me just show you. The standard formula is enthalpy H prime is equal to enthalpy of dry air plus percentage saturation, the percentage humidity divided by 100 multiplied by enthalpy of saturated air minus enthalpy of dry air. This is the formula. So using the psychrometric chart, you have calculated enthalpy of dry air, you know enthalpy of saturated air, percentage saturation you have also calculated. Okay, corresponding to point B, just now I have shown. Put all the numbers and you can get the value of enthalpy of air water vapor mixture. So thank you very much for listening to the video.